Hey everyone, it's Dr. Walker. Let's look at an example from video 106C on energy and satellite motion. This example is called escape speed, and it says, what minimum speed is required to escape Earth's gravity? So this is kind of a theoretical question, right? How fast would this object here that's on the surface of the Earth, how fast would it have to be launched in order that it can go so high so far that it is not under the influence of Earth's gravity anymore, so that the gravitational force between the object and Earth is now zero. This is a good application of conservation of energy because this is an isolated system. The object of mass m is only under the influence of gravity. There's no air resistance, nothing like that. So we set up this problem as the kinetic energy initial plus the potential energy initial equals the final kinetic energy plus the final gravitational potential energy. The initial kinetic energy is 1/2 mv squared, and the initial gravitational potential energy is negative gmm over r, where m is the mass of the Earth and little m is the mass of your object that is escaping. Now we have to figure out, well, what's going to be the final kinetic energy and a final gravitational potential energy? Well, if it's so far away that it's not under the influence of Earth's gravity anymore, it's going to stop, right? Because it's not going to have any more force on it anymore. It's going to have reached such a height that it's the maximum height possible. So the final kinetic energy is going to be zero. And basically, in order for this to happen, the object has to be at a distance of infinity away from Earth. That way, the gravitational potential energy is zero. And that means that it has escaped Earth's gravity. There's no more potential energy between the Earth and the object. So both of them are going to equal to zero. And now we go ahead and solve for v initial, which is that escape speed. Notice that the mass of the particle does cancel out. So we have v initial squared equals, we can multiply everything by 2, equals 2gm over r, and then we can take the square root. So the escape speed is the square root of 2gm over r. It looks very similar to the speed of a circular orbit, which is square root of gm over r, but this has a factor of 2 here. So we need to plug in the mass of the Earth and g and the radius of the Earth. So we're going to plug in all of those values. I'll define them on the side here. G is our 6.67 times 10 to the negative 11. The mass of the Earth is the 5.97 times 10 to the 24. And then the radius of the Earth is our 6,370 kilometers, approximately. We're going to plug in all of those values, and that is going to give us a speed of approximately 11.2 kilometers per second, which is more than 25,000 miles per hour. So again, this is just a theoretical exercise. How fast do you have to be to escape the gravity of the object that you are bound to?